Hi everybody and welcome back. In this lecture we are going to take a look at computed tomography, or in short CT. In the previous lecture we have talked about the generation of medical images using X-rays. Computed tomography uses the same principle but in a more sophisticated way. In a CT scanner, the X-ray source and corresponding detector rotate around the patient and acquire images from multiple different angles. Using this information, three-dimensional scans from inside the body can be reconstructed. In this figure, you can see how such a scanner looks like. The patient is placed on the examination table, which then moves through the scanner to produce three-dimensional images of different body parts such as brain or lungs. As one acquisition only takes a few seconds, computed tomography is also heavily used in emergency medicine to detect, as an example, a stroke. So, now the question is, how do those images actually look like? Similar to projection radiography, the image contrast in CT scans is generated by different degrees of X-ray absorption. In contrast to normal X-ray images, the degree of X-ray absorption and thus the image intensity can be quantified in absolute values called Hounsfield units. As an example, air has -1000 HU and water has a Hounsfield unit of 0. Usually, high X-ray absorption leads to high image intensity, whereas low absorption leads to low intensity. Typically, CT scans are never inverted. Another difference to projection radiography is that distances between single voxels, a voxel is a pixel in the three-dimensional space, can be exactly quantified and directly correspond to the physical distances. On this slide, you can see an example of different cross-sections through a CT scan. On the left, you can see an axial section or slice of the abdomen. In the central image, you can see a coronal slice or section covering a region that shows part of the lung up to the pelvis. And last but not least, on the right, you can find the sagittal slice or section. Regarding the axial slice, you can see the liver here, that's the stomach. Here you can find the left kidney, this is the spleen, and this bright spot here is the spine. The spine clearly shows that bones again have a high image intensity due to their large X-ray absorption. In contrast, the lungs within the coronal scan have a very low image intensity as they are filled with air. Let us conclude this lecture with a comparison between an X-ray image and the corresponding CT scan. Here you can see an example how CTs can provide better diagnostic confidence compared to projection radiography. The fracture of the third vertebra can be detected much easier and more accurately on the CT scan compared to the corresponding X-ray image. Alright. In the next lecture, we will take a look at magnetic resonance imaging. Thanks, and see you soon.